Hello, Andrea.
Hello, Bob. Good evening and good morning to all of you.
Good morning, good evening to everybody.
That's probably is good evening, good afternoon for the ones that in APAC region. We have this new webinar and now we wait another few minutes. People are connecting. This is a free webinar from GMI dedicated to the EX mistakes. And let's wait another few seconds if you...
You bet, you bet.
Yeah.
Yeah, we had a lot of good questions. So we're going to try to answer as many of those questions as we can at the end of the webinar here. So appreciate all the interest.
Yes. For information, please don't use the chat box, just a Q&A if you want to write anything. We are here, we hear you, and we try to answer to your questions. At the end, there is also a Q&A session with the most common question you may have. But if you have others, you can write on Q&A, and we'll try to answer during that. Okay.
All right.
Okay, we can start, Bob. Okay. Thank you again for coming and for attending. Let us introduce ourselves. There is Bob Johnson here. Bob Johnson is, let's say, a very experienced guy in work for Kraus-Heinz, and now is president of Source IX, is distributor for GMI. He's also may perform a lot of inspection for client for EX. He's a member of US UL STB for the adoption of the 79 standards and all aspects related. Myself is Andreas Polaor. I'm a global account manager at GM International. I'm responsible for major accounts. And I'm say assisting Bob in this session, which will be really his session. Okay, Bob, we can go through a presentation of what GMI is a company is offering this free webinar. Is a company designing and produce a complete range of intrinsically safe and seal certified devices for most common and critical application in for DCS, CSD, fire and gas, BMS, in oil and gas mainly, petrochemical, mining, food. Where there is hazardous area critical application, we have solutions. 40 years experience, founded in 1993, produced completely in our facility in Milan, but we also have a global presence in all 5 continents. What about our production? We have a complete state-of-the-art technology with a pick-and-place machine, complete traceability for incoming components and outgoing products, a full testing on all units, 100% of product have been tested, and also we are, of course, ROS and REACH compliant, and also SC, Systematic Capability 3 certification for the design of the products. Next, this is the product range. We produce IS isolators of barriers, CO3 safety relays, isolators for non-AS application with the seal certification, seal certified power supplies, multiplexer for temperature and digital signal, termination board for most common PLC and DCS in the market, HART is our specialty as well, HART multiplexer, surge protection indicators, and also the last bullet is regarding the functional safety and the EX trainings that we are offering beside the webinar. So if you are interested in that, just let us know. The presence are some numbers. We have 10 offices. Next will be also the 11 will be in Mexico. We just opened. We are opening. We also have different distributors all over the world. 200 people or less staff, and also some numbers about the functional safety courses and the number of installation. The next slide is regarding our market divided by system vendors, EPC, OEM, and the user. So we provide different product for different applications, such OEM, the people that make some special things, as special machine. And also, of course, we are in the system vendors market, where the seal is required, where the EX application is required. Okay, we go quickly to the topic of today, and now I'll leave Bob. Thank you, Bob.
All right. Well, thank you, Andrea. And thank you very much for joining us. It is midnight here, or a little after midnight in Houston, Texas. So it's been a long day. So I apologize if I slur a little bit, but I do have some coffee here to kind of keep me going. So there's a lot of information that I'm going to cover. And these are the biggest EX mistakes that I see. These aren't necessarily the biggest EX mistakes that you will see, but these are ones that, as an inspector, as a person who does design work in the EX world and sees a lot of EX equipment actually out in the field, these are the kinds of things that I typically will find that are issues. And so I kind of wanted to bring these to the forefront. Some of these are pretty obvious, some of them maybe not so much so. And again, these are only my interpretations of the things that I see. You could certainly see different things, and certainly encourage you to share with us things that you might see. And as Andrea said, we have a Q&A at the end. Many of you have submitted some questions, so we'll try to address those at the very end. So we'll kind of plow through everything. So starting off, the biggest EX mistakes. Where do these mistakes come from? And I remember when I first got into the EX world many, many years ago, I was more on the design side, engineering side. And I used to always think it was always those idiots out in the field that were making the mistakes. But actually, when we start looking at some of the root causes of some of the major industrial accidents, we find that in many cases, actually in a majority of cases, it comes out of the specifications. So either the specifications are poorly written, or they're misinterpreted, or for whatever particular reason. So even though we have issues and we think that maybe it's the operators or the guys that are installing equipment, but in many cases it actually starts very early on in the project. So, you know, making sure that these systems are safe really starts at the very early stages, and it carries all the way through the life cycle. So how do we define mistakes, or where can we find the answers, if you will? So there's a couple key standards that I find myself using all the time, and you will find variations of these throughout the world. But we follow, in effect, the IEC 60079-14 standard, which is our design guide and installation guide. And the 17 standard is our inspection and maintenance of EX equipment. So those two standards, if you will, are very much where we're going to find a lot of what we need to be doing. So these are very handy guides. And of course, in Europe, we follow the EN version of these standards. Here in the United States, we've actually published now a UL version of the -17 standard. And there are variations of these standards that exist throughout the world. For example, in Australia, ASNZS 60079-14 and -17. In many cases, these standards that are published with variations are all based upon the IEC standard, and they just get tweaked a little bit for the local markets. So as an example, how do we define some of these mistakes? Well, the inspection tables that we are given throughout the -17 standard gives us some specific things to look for when we're actually doing inspections. I know we have a couple inspectors online here, and you guys are probably very familiar with this standard. And I always tell people, I say, even as a designer, right, if you're designing a skid or you're designing a system and you're going to have a third-party inspector come in to your facility and look at your EX equipment, I always tell people it's good for the designers and engineers to understand what the inspectors are going to be looking at. So these inspection tables are critical. If you do this, when an inspector such as myself comes into your facility and starts looking at things, you'll know exactly what I'm going to be looking for, right? So it's important that not only inspectors should be aware of this, but really everywhere within the supply chain should be familiar with these inspection tables and inspection charts. So what's the most common mistake? Well, really, this is somewhat of a generalization. And many times this is, you think of it, it's kind of like, well, wait a minute, this is so silly. This shouldn't happen, but it happens all the time. The equipment isn't suitable for the gas group, the temperature code, the zone, the ambient temperature, IP ratings, certification, or environmental conditions. All of these are critical things to understand before we're actually going in and doing inspections, or making sure that whatever those client specifications, to make sure that we're selecting the appropriate product based upon the parameters that we are given. Or we need to make sure, if we're writing those specifications, make sure that our specifications include this information, so your subcontractors will make sure that they comply. It's always horrible when you have to guess and you have to go back and forth and not understand, and maybe some of this information is left off a specification, then you have to go back and try to find out that information later on. So here's an example just of a nameplate here, right? You see it's the requirement is zone 1 gas group 2C T6 plus 50 degrees C ambient IP65 IECEX certification. Now, we've done this in other webinars, but understanding a label is very important. And by looking at that label over there, we can actually see that in this case, this particular product is only suitable for plus 40 degrees C. And if you notice, it does not say anything about IECEX certification. What's a giveaway that's telling us that it's ATEX? Normally it would have an ATEX certificate number, but we also find the little EX and the CE mark that's telling us that it's ATEX compliant. So right then and there, we discount this product based upon 2 factors. Looking at this particular piece of equipment, again, similar situation. What are some of the issues? Again, ATEX only. We're suitable for zone 1 based upon the protection concepts, but we have some issues there. And the big issue, again, this was only ATEX, so therefore this would not be suitable for this particular application. Here again, zone 1, 2C, T6. Well, there's a couple things on this one, and it spells it out actually fairly clearly on this one. This product is only suitable for zone 2. And there's a dead giveaway when you see the markings under class and zones where it actually says zone 2. So, but the protection concepts here are telling us it's zone 2 only, and the EPL is telling us GC is zone 2. And the other thing is that it actually is a component certified product. We see that with a U. That means it's a component certified product. It's not a final certified product. We'll talk more about that a little bit later on. It also does not have a T code associated with this. Now, here's an example of another product that in this case, it actually is zone 1, but it's 2B plus H2, not 2C. So it meets all of those other requirements, the plus 50. It has IECEX certification. It is zone 1 rated. However, in this particular instance, it does not meet the gas group, and it does not meet that T6 qualification. So, I know I'm kind of telling you the same thing over and over again, but this is always a big issue, is making sure that these products are suitable for the environments. So I'll skip this one and we'll move on, because I don't want to just keep telling you the same thing over and over and over again. But here's another example. This one is zone 2 ATEX only. And in this particular instance, again, this one is zone 2 ATEX only, also doesn't meet the IP rating. So our first poll question: what is the IEC standard that provides guidance for the inspections of EX equipment and installations? So Andrea, do you recall?
Yeah, already launched it.
Yeah, go ahead.
Let's see what is the reaction for the attendees.
So I mentioned two particular standards at the very beginning. And I see that you're answering both of them. So that's good. You guys are paying attention. But there is only one correct answer.
Okay.
All right, we'll give it another few seconds here.
Yeah. Please make your decision and let's stop it. Okay, we're gonna stop it. Okay. Now we can share the results and.
Okay, yeah. So a majority of you got it right. The 17 is the standard that we follow for inspections. I did not mention what -1 was. -1 is actually the standard for flame-proof equipment. So if we're building a flame-proof box, we're building it to that particular standard. The 14 is the design and installation standard. So 14 and 17 kind of go back to back. We start off with 14, that tells us how to design it, how to install it. 17 is telling us how to inspect it. 10-1 is actually the area classification standard for gases and vapors in hazardous locations. So well done.
Okay.
All right, let's continue on here. So mistake number 2, modifications to EX equipment outside of what is allowed. So some of the things that are big no-nos: additional entries drilled into EXD enclosures, adding additional components inside the enclosures outside of what is allowed by the certification. There's addition of items such as O-rings, Teflon tape, labels to existing EX equipment. Now, additional entries is specifically a no-no for flame-proof enclosures. However, you can, depending on the manufacturer, you can make additional holes into EXE enclosures. So this applies to flame-proof enclosures only. Adding additional components. The issue is that when we start adding additional components to, say, a kit of EX equipment that's outside of the scope of the certification, what happens is that when we're adding more electrical devices on the inside, this will generate additional heat. So therefore, now we have to reevaluate our temperature rise to determine our T codes, our temperature codes with our particular piece of equipment. So it's important that we don't add additional items. It is always okay to change a like for like. So if we had, say, for example, a motor starter that had an ABB motor starter and it fails, we replace it with a like ABB motor starter, that's okay. There's always a question of whether or not, if we replace it with an item that's not the same, say from a different manufacturer, that's usually, you should check with the manufacturer. Things like adding O-rings. A lot of EX equipment will have O-rings, they'll have gaskets, but we want to make sure that we don't put them in where they're not supposed to be, or if they get damaged, we want to replace them by whatever the manufacturer recommends. Teflon tape is a big issue with cable glands. We don't want to put Teflon tape on any of our cable glands. Cable glands, the threads there going into a flame-proof box, that's actually a flame path, and by putting Teflon tape, that impedes the flame path. We only allow things like a non-hardening, non-setting grease or thread lubricant to threaded entries. Things like labels. Labels can be a little bit difficult. When we start putting labels on EX equipment, if we're actually drilling into a piece of EX equipment, be very careful, because we could be potentially damaging the piece of EX equipment, or we could be violating the ingress protection rating, depending on the type of label that we're putting into it. So be aware of that. That's just something that happens. We want to make sure that we follow the manufacturer's recommendations if we're adding additional labels to any EX equipment. So here's just a couple examples. On the left-hand side, you can see our wiring is a little bit jumbled up, right? It's pretty messy over there. On the right-hand side, excuse me, what we have there, we have a cable gland going into an adapter with actually an IP washer. And it looks like actually over here, we've actually got a thread adapter here, and we have a thread adapter here. So we actually have two thread adapters, which is not allowed. So we don't want to have multiple thread adapters. Now, looking at this next slide, down at the bottom, what we see here, this is obviously a flame-proof box, and we have a bunch of different cable glands down here. We have some cable glands that they're for unarmored cables. Some of these are for armored type cables. And all of those glands, I can tell you, are EXD. The one thing we don't know, however, with this particular device is based upon the latest IEC standard, we may have to be required to use a barrier gland for those types of cable glands going into a flame-proof box based upon the length of the cable that's exiting from that enclosure. In general, if our cable lengths are longer than 3 meters, then a non-barrier gland generally can be used. If the cable lengths are less than 3 meters, meaning the cable that goes from, say, this cable gland goes over to a transmitter right over here, and it's only 2 feet away, at this point, this would need to be a barrier gland. So we have to understand not only the protection concept of the glands themselves and where they're going, but also where the end device is going to be located. Because if we don't know that, then we don't know necessarily whether or not these glands are suitable. So be aware of that. Now, this is a very interesting one here. This is somewhat along those same lines. This is two different manufacturers of a similar product. This is a flame-proof box. But if you look very, very closely here, you notice that this mark is EXDB. This one is EXD. Both of this is the latest marking requirements that you will find under the IEC standards. This is the legacy marking. Both of them are fine. However, notice this right here. We also have EXIA. That means that what we have done is that on the inside of this flame-proof box, we have an intrinsically safe barrier. This product does not show IA, meaning that it is not allowed to put associated apparatus on the inside of that enclosure as the way it should be marked. So if we opened up this enclosure and we looked at it, we saw a bunch of intrinsically safe barriers located on the inside of this flame-proof box, we'd want to have a marking similar to what you would see at the top. So that's a little minor issue, but it is something that is that's fairly common. There's our example of the Teflon tape on the left-hand side. And there's on the right-hand side a combination of certified stopping plugs and non-certified traveling plugs. So the non-certified traveling plugs would definitely be an issue. So this kind of gets into mistake number 3. Again, on glands, this is always a big issue. Non-certified glands, improper installation, not using the appropriate accessories, using EXE accessories into EXD enclosures, failing to take note of the special conditions for safe use in the installation of cable glands. All cable glands will have an X at the end of their certificate, meaning that they are designed for fixed equipment. Now, some cable glands will actually have in their special conditions for safe use, depending on the cable type, depending on the gland, they may actually have an additional clamping requirement for somewhere between usually around 300 millimeters at the end of the gland. If you don't pay attention to the X condition and you start doing an installation of cable glands, and an inspector like me takes a look at it and sees the X condition, says, hey, you need to clamp those cables within 300 millimeters to be in compliance to the certificate, it's important to understand. So using stopping plugs within a reducer fitting, that's not allowed. And then, of course, using multiple reducer fittings. And then when we start opening up glands, we start seeing that maybe they're not terminated properly, like what you see on the left-hand side. Over on the right-hand side, what you see is actually a plastic traveling plug. So that's typically what is supplied by the manufacturer just as a means during the traveling of this product to keep moisture, dust, dirt out. It is not it is not meant to be left in place. It shall be replaced with a certified stopping plug. So that's a pretty common thing that we see an awful lot. A lot of traveling plugs are left inside of EX equipment. Now, this is a little interesting one on the right-hand side. Just by looking at this product right here, this looks like a flame-proof box, and it is a flame-proof box. On the left-hand or on the right-hand side here, what you see is actually a plastic gland. Now, if you know anything about glands, plastic glands are generally never EXD. They are only EXE. However, that box is EXD. Now, by looking at that, you might assume, hey, this product cannot be right. You must replace it with a certified EXD gland. However, if that transmitter was used as intrinsically safe, that may or may not be the case. So you might have to do a little bit more research. On the left-hand side, what you see over here is where we've got a combination of a bunch of accessories. We have reducers, we have oboes, we have adapters, and finally a gland. You know, that generally would not be something that we would want to see. We'd want to minimize the amount of those types of products going into a flame-proof enclosure. Here we see some examples on the left-hand side of non-properly poured seal fittings. So seal fittings or stopper boxes are typically used as opposed to a barrier gland, where they're packed with a compound material. And these were obviously not doing any good because these were cables that were run into entries and these were not poured. That's obviously a huge issue. And then on the right-hand side, with the cable not being terminated on the back end of the gland, it pulled out. So therefore now we don't have any environmental protection. Looking at these pictures here, here's where we've actually taken some compound and we've packed these glands after the fact from the inside of the enclosure. This is not how barrier glands shall be installed. What you can see very, very closely, if you look right here, there's actually an IP washer, but it looks like that IP washer is the wrong size. If you notice, there's a small little gap there. So we basically at that point have not got appropriate protection from the gland to the enclosure. And again, that's a minor little thing, but just by looking at it, you might glance at it and not see that. But that's an example of something in which, if it's a requirement to maintain an IP66 in the environment, we've got the wrong IP washer. That's a 20-cent item. You know, we would need to replace it. We need to put a new IP washer on there. So those are little things, but those are things that inspectors are going to be looking for. And again, these are just other pictures that you can see where maybe glands are not properly terminated or they get pulled out for whatever particular reason. So it's imperative that we always look at this. Same thing with these particular glands, same issues. Here's actually another picture here where they're taking the compound and they're actually packing it around the back end. This is an issue with certain gland types. This happens to be a hawk gland, and it's an important thing to remember that if we're using this gland or any gland with an inner seal going into a flame-proof box, that this plastic sheathing is removed. That plastic sheathing shall be removed so we get a good flame-proof environmental seal between the diaphragm and the bedding of the cable. We don't want to have plastic there. So those are some little things. Again, these aren't necessarily huge things, but these do affect its EX protection. Excuse me. And of course, here's another example where, in this case, on the left-hand side, we're using barrier glands, but the compound wasn't properly done. And on the right-hand side, where we have a torn up diaphragm seal. So glands are typically a big issue with regards to inspections, making sure that they're done properly. That's usually one of the first things I always look at. Now, here's an example. Is this a mistake? We have a non-barrier gland next to a barrier cable gland into an EXD box. Actually, this is not a mistake. Because the standard does allow the use of a non-barrier gland for cable lengths that are longer than 3 meters. So the glands on the left-hand side, those were for cable runs that were beyond 3 meters. The cable gland on the right-hand side was actually to a device that was about 1 meter away. So that's actually a correct installation, even though looking at it, you might think, wait a minute, we've got 2 different types of glands going into the same type of enclosure. So another poll question, Andrea.
Yes, launch it. There is a question from one attendee if you want to look. In the meantime, Bob.
Oh, yeah. So somebody just asked a question. Slide says 600069-17 for inspections. The question goes 60079. So if I may have made a typo, Madhu, it should be 60079, or excuse me, yes, 60079-17. So thanks for catching me.
Small mistake on the presentation, probably.
Yeah. Yep. Excuse me. So the question is, can you use an EX certified stopping plug in conjunction, excuse me, with an EX certified reducer fitting on an EXD enclosure? So here's the example. If we have an enclosure that's got, say, an M32 hole, and we have an M25 gland, or say we don't have a gland, but we have an M32 reducer, and then we have an M25 plug. Can we go ahead and use those 2 together? Yes or no?
Are we going to stop it?
Sure.
Let's share it.
So
Parity,
yeah.
10-10.
We're split 50-50. So the answer is actually no, you cannot do that. You must use, when it comes to stopping plugs into EXD enclosures, they must be the size of the hole. We can't reduce down and then put a stopping plug. We can't reduce a reducer, and we cannot reduce and use a stopping plug. We can use a reducer to go from a bigger hole to a smaller hole to allow a cable gland, but not for putting a stopping plug. Excuse me, I got a frog in my throat here. Apologize.
Okay.
So mistake number 4, intrinsic safety. No segregation between IS and non-IS. No labels indicating IS circuits. Improper grounding of IS circuits. No descriptive system documentation. Failure to select certified equipment where required, i.e. non-simple devices. And modifications to design after installation, such as increasing the cable length, substitution of a different barrier, etc. These are all issues that we find on intrinsic safety that we have to make sure that we take into account. Now, again, some of this could be at the very early stage in the design stage, but in many cases, this could be after the fact. So what we're seeing on the left-hand side, we have a combination of power and intrinsic safety in the same enclosure, which is allowed, but we've defeated the 50 mil separation when we started to do looping on the inside of the enclosure. The same thing holds true on the right-hand side, where we start seeing looping, excuse me, when we start looping around, because now we have our, if you will, this is where our incoming power is coming into. This is our outgoing to our IS, but if we start looping this around, now we have to maintain a separation of 50 millimeters with these cables from the power to the IS, and we've obviously violated that with this. So that's a major issue with intrinsic safety. Same thing holds true here. What we have, they've actually got a partition right here, but we have some IS, and a partition is allowed, but this distance up and over must be at least 50 millimeters. And in this case, it wasn't. The other issue is that this was an IS cable, this was a power cable, and we've not maintained our 50 mil separation. And unfortunately, these were barrier glands. So this was a situation where the glands need to be removed and unfortunately reinstalled. Mistake number 5. This is where we're using a U certified component product as opposed to a product that has an X certificate. So this is very common with regards to junction boxes or enclosures. Manufacturers will provide you an empty enclosure with no terminals, and it will come, excuse me, with a certificate, and you can barely read that, I'm sure, but there's a U at the end of the certificate. That is telling us that it is a component, meaning that we cannot take that product and populate it with terminals and just put it out in the field without further evaluation. So this is a very, very common mistake that a lot of people make. So make sure that all your enclosures, when you start assembling them, they're fully certified. We don't want to see products out there with a U component cert unless they're part of an overall assembly, such as a terminal block or a switch or something like that. This is an example of the same product, same part number, but one has a component cert and one has an assembly cert. So, excuse me, the way you can tell very easily, besides just looking at the U, on the right-hand side, you'll see things like the temperature ambient. You'll also find a T code. On the left-hand side, you don't see any ambient temperature. You don't see a T code. On the right-hand side, it says that it comes with 10 terminals rated 2.5 millimeter. On the left-hand side, the enclosure doesn't say any of that. So what happened in this particular instance, the enclosure on the left-hand side was an empty enclosure. The enclosure on the right-hand side is the exact same enclosure, except it had 10 terminals. So we can't just take terminals and stick them on the box on the left-hand side. Mistake number 6, not taking into account the conditions for safe use. So every certificate, every product that has an EX rating will have, if it has an X condition, will have in their certificate a specific condition for safe use. And you have to get a copy of the certificate to understand this and read it. So when you get that as an inspector, we're going to be looking at that information, and it's going to tell us things like how this product shall be installed in order to meet the safety requirements. So it may say things like in the example there on the top one, that's for a heater unit. It's based upon all the information. It tells you how it should be installed. On the units below, or the condition below, it'll say things like taking into account the fluid effects. There's an electrostatic discharge hazard. So there's things in there that we need to pay attention to when we're maintaining this EX equipment. Improper wiring techniques. So not tightening up unused terminal blocks, too much copper showing on connection points, undersized earthing conductors, using cables with non-barrier EXD glands. So those are all, again, some other big mistakes that we see. And I'm going to kind of skip through this because I know we've got a lot of Q&A that we want to get to as well. Lack of proper maintenance on EX equipment. Mistake number 8, right? On the left-hand side, obviously, the bolts are missing and it's just held in place with a piece of wire. Not good. On the right-hand side, it looks like we have some corrosion issues with the flange. So maintenance on EX equipment is critically important. And obviously on the left-hand side, we're allowing water to get on the inside of our enclosure there. And on our right-hand side, obviously, we have an issue with the gland and dust and dirt and all kinds of problems there. Mistake number 9, earthing of intrinsically safe Zener barriers. One of the things that's important to note when we use Zener barriers, they require a dedicated earth. This is called a clean earth. In many cases, what we will find is that people will tie in the clean earth to the dirty earth. This is a requirement that you cannot do this. The resistance for the clean earth needs to be no more than 1 ohm resistance. So it is critically important anytime that we are using Zener barriers that we're using a clean earth. One of the things that you will see sometimes when we're using Zener barriers, especially if we're mounting them into a metallic enclosure, well, the DIN rail is tied into a Zener barrier. Well, if that DIN rail is attached to the metallic enclosure, then now that's tied into the dirty earth. So we need to make sure that we're using some isolated standoffs, some insulators, to make sure that we keep that DIN rail away from the dirty earth. I think this is our last poll question, Andrea.
Yeah, right. The last poll.
Our last poll, I think. Yeah.
Yeah.
So what letter at the end of the certificate number signifies a component certificate? Well, so far so good. You guys are getting it. I apologize. I lost my voice here. It's been a long Monday.
Was it a long one?
I think I swallowed wrong. So we'll let this go for another few seconds here. So I will tell you right now that most of you got this right. So we'll go ahead and end the poll now and share the result. Oh,
sorry, push the
oh,
time. Do it,
Here.
do it.
I got it. I got it. So a majority of you are correct, right? A component certificate, a U at the end of that certificate is telling us that it's a component. An X is telling us that it has some sort of condition for safe use. So those are the 2 letters that you will see at the end of the certificate. Realize if it's a U and it's a final product, you need to reject it immediately. If it has an X, we have to do some digging and find the certificate to make sure that that product is installed in accordance for whatever the conditions for safe use tells us. Okay, stop sharing, close that. So to summarize here, and we're going to do a little bit of Q&A for the last 10-15 minutes. So mistakes can happen, right? It's not limited to just the installation errors, because errors in design cannot be overcome by good installation practices. So I've demonstrated a couple glaring mistakes, but these are just a handful of the errors that you can see, and they're made up. And again, it's really important, not just for the inspectors, but everybody within the chain, to make sure that we're catching all of these mistakes at the very early stages. Because, I mean, obviously it's good business to make sure that we don't spend time reworking things, but this is a safety critical industry. We have errors, and this is where we have disasters, and we don't want to be that one who's responsible for not catching an error that ultimately could result in the loss of life. So that's critically important. Now, let me close this, if I might. And stop share for just a second. Okay. Andrea, can you see that?
Yeah, that's perfect.
Okay. So a couple questions that came in, and try to answer these as quickly as possible. We have quite a few. So difference between flame-proof EXD and increased safety EXE for power applications. You know, what's the big difference? So flame-proof on the right-hand side is a good example of a flame-proof enclosure. Flame-proof enclosures will allow ignition-capable equipment to be used inside the enclosure, while increased safety does not. So on the left-hand side, that's an increased safety enclosure. Those are increased safety terminal blocks, and those terminal blocks have certain creepage and clearance requirements, and that's not considered to be arcing and sparking if they're installed correctly. So therefore, on the left-hand side, again, perfectly suitable for zone 1, just like what you see on the right-hand side. However, the components that you're putting on the inside of an increased safety enclosure all must be certified. The products that you're putting on the inside of a flame-proof box do not require any EX certification. So again, if you have an application where you've got high energy arcing and sparking devices like contactors, relays, things like that, that don't have an EX certification in and of themselves, you know, in many cases, flame-proof is certainly a viable solution. There are other protection concepts like pressurization that can be used, but certainly flame-proof is one. This was an interesting one. Why must we use EX equipment near industrial furnaces which have a source of an open flame? So if you have an open flame, right, and obviously there's fuel, there's ignition sources, are we expecting to have a flammable gas air atmosphere in that environment? Probably not. We should be obviously, hopefully having that flame burning it off. However, there are some instances, and I've seen this, where more or less, if we have a fault condition and maybe the furnace has been extinguished, but yet we have a release of gases that are used to fire the furnace, maybe it's a gas-fired furnace, and then we have a release of gas. So you would have an application where you might need EX equipment, might be zone 2 EX equipment located near a furnace. So it wouldn't necessarily be during the operation in which the furnace is operational, but it would be there in the case of an unintended release of flammable gases that is used to feed the furnace. So there was a question on the UK certification scheme, and this is becoming a big topic, obviously, if any of you are in the UK about this. So with the UK pulling out of the EU under Brexit, the UK government has come up with new UK EX regulations. These will go into effect January 1st of 2023, so about 11 months from now. And
they postpone 1 year.
I'm sorry?
They postponed 1 year. It was this year, they postponed 2023.
Yeah, postponed. It was supposed to go into effect this year, but they postponed it. And these will replace the ATEX requirements within the UK. They still will require testing for Zone 0 and Zone 1 equipment by a UKCA government-approved body, which are very similar to your notified bodies, but generally they're going to be UK certified bodies. And instead of referencing the EU directives, you would now need to reference the UK legislation. So instead of ATEX Directive 2014-34 EU, products must meet the UK equipment and protected systems intended for use in potentially explosive atmosphere regulations from 2016. So from a pure product standpoint, the standards are more or less the same. It's just an additional step that you're going to need to take in order to get your product certified for use in the UK. So it doesn't mean that the products are really changing. It's just going to be additional markings and an additional step for the manufacturer to get their certification done around. When selecting EX equipment, where should I find the relevant information as to the installation instructions? So certainly the manufacturer's data sheets along with the installation documentation is certainly important. And again, it's always advisable to obtain copies of EX certificates from the manufacturer before selecting the equipment and to read fully the scope of the certificate along with any conditions for safe use that may be required for a safe installation and operation. I tell designers and engineers all the time, and we sell product, right? We're a distributor for GMI. I always tell engineers, designers to don't buy any product until you've had an opportunity to look at the certificates. Because, you know, manufacturers will put out beautiful information, very nice. They tell you it does all this great and wonderful stuff. And they do, but the devil is in the details. We want to get copies of the certs so we understand any pitfalls, any limitations, anything about that particular product that we need to be aware of from an EX perspective is going to be on the certificate. So we want to look at those very closely. And I always tell people, again, get a copy of them before you actually start buying products. It will save you some heartache and headache down the road. How to properly ground the wire screens. And this is, I assuming, was on an IS question. So this little drawing here is basically the cable screens are usually earthed at one point, normally at the non-hazardous end of the circuit. This is required to avoid the possibility of the screen carrying an incentive level of circulating current. So what we see there, we have a dirty earth going to ground. We have a clean earth, right? And our cable screen wire is coming through our clean earth terminal. The screens continue on to the next cable, and then the screen wire is not connected and it's left floating. So in that particular instance, any stray currents would flow back into the safe area or the non-hazardous area, if you will. So that's the way we want to treat our screens. Let's see if I can read this. What precautions should be taken during maintenance of such equipment and systems, including, close that, during maintenance of such equipment and systems, including planning and steps before and afterwards? So details on maintenance of EX equipment are defined under the -17 standard. So the types of inspection that are initial, we always have to have, when a product is brought into service, it is always a detailed inspection. And then management will make determinations as to the inspection schedules after that. Are they going to be periodic, sample, continuous supervision? What grades of inspections? Are we going to do visual, close, or detailed, or a combination? How frequently? We're going to document our lockout tagout procedures. And certainly we need to document the competency of the personnel that are responsible for doing those inspections. So these are all the things that are spelled out within the -17 standard. So when we have students go through the IECX COPC program, this is a big portion of what we cover in detail. Can EXD enclosures have removable gland plates? If a gland plate is removed for maintenance and reinstalled, does it need to be re-inspected formally? So EXD enclosures do not have removable gland plates because they are typically a fully sand or pressure cast enclosure. However, EXE enclosures do and can have removable gland plates. Generally speaking, if a gland plate is being replaced, or a new one's being installed, a full detailed inspection of the gland plate should take place. By the way, gland plates are not a requirement. They're a good idea, however. And the reasoning for that is that the reason why manufacturers typically have gland plates is that, as I mentioned earlier, you can actually punch holes or drill into EXE boxes. If you screw up on a gland plate, then you don't have to worry about replacing an entire box. You just need to replace the gland plate. That's a big issue. And secondly, it's much easier, especially when you start getting into larger cabinets, to take a plate and do some drilling on a plate as opposed to a large enclosure. Excuse me. After initial installation and commissioning of an IS system, what is the recommended periodicity to validate the system? What is the procedure to check an IS loop without disturbing or shutting down the process? So the -17 standards mandate that every piece of equipment shall be inspected at least every 3 years. Now, with that being said, that doesn't mean that we have to de-energize every piece of equipment and do a full detailed inspection. That just means that we need to, at least within 3 years, take a look at it. You know, if nothing has really changed in the environment, there's no serious corrosion or anything like that, then we can, we can validate it in that way. An IS system loop can be verified under live conditions because it's inherently safe. An example, heart signals can be sent to a transmitter to force signals to any level without affecting the safety of the loop. So we do want to be very, very careful, however, when we're doing testing on IS circuits in the field. We need to make sure, number one, the equipment that we bring into the field, if we bring a standard meter into a hazardous location, by that meter itself could be a potential source of ignition. So either we have to have a gas-free permit, or we have to make sure that that device is suitable to be brought into a hazardous location. Also, if we're actually testing an IS circuit, it's very easy to blow the fuses or damage the resistors on the inside of IS circuits. So there's typically a procedure in which you want to follow if you're ever testing your IS circuit, doing insulation resistant testing, which does say that you're supposed to do it periodically. Excuse me. Can I install an IS barrier in the field in a remote area? So generally, intrinsically safe barriers are certified for zone or division 2, as long as the enclosure is suitable for the environment, if you will. However, they can be installed in a zone div 1 as long as they're providing or being provided some sort of suitable protection. So could be a flame-proof enclosure, could be a pressurized enclosure. Those would be 2 examples of maybe installing ISBs in a hazardous location that is zone 1. We had a situation here where not too long ago, actually, customer had an issue where the length of cable had to be very, very short based upon the ignition curves of the particular application. And the cable length actually had to be a couple 100 meters long. Well, the control room where the barriers were going to be located was going to be beyond that distance, and that was going to exceed the capacitance and the inductance ratings for the cables. So what we recommended in that instance was to take those barriers and actually install them in a flame-proof enclosure, locating them much closer to the end devices, so therefore we could stay below the inductance and capacitance built up from the cable. So there's different ways to kind of address how these situations, how you may need to install ISBs to make them safe. Is it possible to install a non-certified simple element like a push button using an IS barrier? Yes, it can be done as long as it's defined as a simple apparatus. So what is a simple apparatus? Could be a thing like a junction box, resistor, simple semiconductor devices, but basically sources of generated energy such as thermocouples and photocells, which do not generate more than 1.5 volts, 100 milliamps, and 25 milliwatts.
So Bob, an
RTD
thermocouples can be defined as simple device?
Yes.
So it
Yes.
needs to be certified. Just a IS barrier would be enough for having the certification for the system. Yeah.
Right. It does not require a certified device. So now you'll find certified thermocouples because some people won't use them in conjunction with IS. They might use them as flame-proof, right? So you can find EXD thermocouples. And so the difference is there, it'd be the same housing. The glanding and the cabling would be different for that application. So which is the hazardous area protection method most used? This is a great question, but it's really, it just depends, right? So for power applications, a lot of flame proof, right? Here in the United States, we use a lot of what is called explosion proof, which is basically the US version of flame proof. However, intrinsic safety is very, very common in other parts of the world. We certainly use intrinsically safe here. High power devices really can't be made IS. They are typically EXD. When large instrumentation panels need to be installed in hazardous location, air purging is a lower cost solution. For zone 0, we're basically limited to intrinsic safety or encapsulation. And sometimes we'll find large high voltage devices such as transformers could actually be oil immersed EXO. So there's not necessarily one protection concept that is best for everything. And in some cases, we'll combine those protection concepts in one particular product as the best solution. And I think we're running out of time here, but yeah, there we go. I think we're done. So.
Yeah, there is a question. What is the difference between flame-proof and explosion-proof enclosure?
Yeah, and that's a good question. So flame-proof and explosion-proof operate in the same fashion. They are designed to withstand an internal explosion. However, the big difference is if you look at them, they look very similar. They have bolts, they're cast metal. However, the requirements to meet the explosion-proof requirements under the UL standards is that these enclosures that are explosion-proof must withstand a 4 times reference pressure, meaning that if, say, that box is suitable for hydrogen applications, and hydrogen, when it explodes, the pressure might be, let's just say, 50 psi. In order for an explosion-proof box to be suitable for that application, it must withstand 200 psi. On the other hand, a flame-proof box only requires a 1.5 times pressure test rating. So typically, a flame-proof box will have slightly thinner walls. The flanges won't be quite as large. You might have fewer bolts, but they're very similar in design. They operate in the same principle. It's just that explosion-proof boxes are much heavier, much more robust, and must withstand a higher pressure. That's basically it.
Okay, we are at the end, probably.
We are at the end. Yeah, I survived.
You survived. Thank you, Bob. Thank you. This is a webinar. You may see other webinars in our program. If you look at the GMI webpage dedicated for trainings and webinars, you find other topics beside the EX, functional safety, SAIL, and dedicated for the power supplies, for the ES barrier, for safety relays, and so on. Those are this is the page, and you can also, this webinar has been recorded, so you may see later on. It will be available on our YouTube channel, as well as the other webinars we did in the past 2 years. So you can have a look at the different topics. Thank you again. Do we have the last poll if you want to answer, so we can just improve our, of course, our webinars? Maybe we can do something more. Maybe it was not what you liked, but I think it was excellent from Bob. I can answer excellent myself,
well, thank you.
If I cannot push the button. Only attendees can do. Thank you for voting, and of course it is anonymous, so you can write whatever you like. No limits on that.
Right, right. Yeah, we try to do our best, and certainly feel free. Yeah, and a question that came up: will the recording be shared to participants? Yes, this will be on the GMI YouTube channel. I think Anna typically gets them online within a day or so.
Yeah.
So if you just go to you just go to YouTube, and there's all different kinds of webinars that we've done in the past that are there. I think we've done, oh gosh, I don't know how many in the last 2 years, but quite a few. So
more than 100 webinars.
Yeah. Yeah.
And yeah, if you don't find it, just write me, and we'll share the right link. But if you go to my YouTube channel on YouTube, you will find it for sure.
You bet.
Okay, thank you. We can stop here, and we don't share it, but thank you. It was more than excellent. Your webinar, Bob.
Well, thank you, Andrea.
Thank you to all of you, and let's see in the next webinar probably. Okay.
Yeah, we'll see you the next time. Thanks, everybody.
Thanks, everybody. Bye-bye.
Bye-bye.
Ciao.